Go ahead and just start to do that now. I'll have around people come in. That's all I can do. Hello. Here's your exam back. Hello. How's it going?
What's up, man?
Welcome to class, Mariana.
I know it today. Damn, you got 4 out of 10, man.
Oh, it's fine.
I think you actually passed.
I passed? For real?
Yeah.
Oh my goodness. I didn't pass the last one. I'm smart. She scared me.
Alright, you're sitting here? Yeah. Yes.
She failed. Did she pass?
What's the
48. Ooh.
It was the hard one. Alright, then Miguel probably won't be here sitting here all day. I can get grades.
This is senior class.
That's you. Your grades are pretty almost the same.
That's easier. I could get 100 if I wanted to.
Dile que te dé una vez y siento.
I could get 100. Ooh.
Use your calculator. Use your calculator.
What you get?
Damn, I'm smart. I got
Yeah, you should probably start hanging out next class here.
Yo le echo ganas porque
Wait, does that mean like 48? No, 59 out of 80? Is that like 70 or does that mean like 80 is passing?
I feel like it's like
Because look, half is wrong. So you got like a 50 something.
I'll explain the
So I got like
practical.
over 70.
Oh,
We're
fine.
gonna like until you're ready.
That's cool. That's like a 50, so
that's like a 50 something.
and then a 50 would be like a 60, or 60 and then güey, pero imagínense, ¿cómo chingados
I guess we're gonna answer
bro? I said 25. I'm the 11.5. I started with 0.5.
You ain't
I
getting
think
it.
it's different. I think it's
I'll talk about the exam in this moment. Work on the bell ringer while you are.
There's a building? Oh.
Yep, there's bell ringer. Oh, I'm so sorry. I didn't see it there.
Low?
I was low and I was 36.
Whoa.
Yeah. Okay.
Alright, well, it's a 5-minute grace period, so. This is it for today.
Alright. I'm not calculating.
Yes. I do. The pencils are always going to be in the basket.
Wasn't
You go
that
take,
too?
you go take 3.
Wait, but which one?
No, Chuck.
One just have fun.
Yeah.
Because there's one like eight.
Oh, no, the side
This is annoying.
No, that's not right. What you mean, Chase?
So our
Oh,
order
we
of
need
operations for
candles.
today, we're gonna do our bell ringer. Then we're gonna talk through several of the problems. I'm gonna talk about some of the most missed problems on the exam. And after we have done that, we're gonna start talking about what is a derivative. Okay, so that's our order of operations for today. First bell ringer, then we'll talk about the exam.
He was and then come late.
We'll talk about that. We're first gonna do the bell ringer, then we'll talk about exam and why some of you may have lost points and you didn't think you were gonna lose points in something. So we'll do that. We're gonna do that.
I see it.
What's that?
Oops.
What name is this one? So first one is
That's the first one.
wait. No. I go.
Alright.
Yeah.
Oh, bro. You're too smart. And then it's the, which are ranking because of. Yes,
I'm giving 5 minutes for bell ringer, so you have 5 minutes to work on that one.
Arriba todo tiene rosa.
Yes. Yes.
That's just my personal opinion. It really
Undefined
does
is what you get if you just plug it in directly. I remember our goal is to figure out what it would be. You can do that. You can also listen to this back roll. You can use factors.
Así es, sí se lo que quiere que haga con la
Compra si puede más que tus puntos. O sea, ¿sí me entiendes? ¿Me entiendes?
Find out.
Tú dime los nombres, pero tú dime lo que quieras.
No, chile, o sea, te lo digo así.
Just tell me, tell me. Me lo reservo. Hay muchos oídos en este parque. Y hay muchos pájaros mirando, muchas bocas en la pared y muchos ojos en el piso.
Undefined is what happens if you just put it in. Our goal is to see if we find names that's not undefined. Yes, undefined is what happens if you just plug it in.
He started counting as well. How was he doing good? He's minus 2 from his new
Double check that.
I think the whole point is that it's
Where do you think?
We got 2 points. -2 is like.
Alright. So I've already been checking the boards. What I'm gonna do is I'm gonna talk through these two really quick, and then we'll do our exam, like go over our exam problems. So there's a couple ways you can solve this. You can use a table and do the 0.9, 0.99, 0.999. You can do that to approximate it, figure out what it would be if you have one, because a lot of you probably figured out that if you just put 1 in there, you get 0, right? Oh, yeah, not 0, undefined, which is 0 over 0. Another thing you can do is, because this is a difference of squares, we can split it into 2 parts. We have 1 times 1 would give us 1 times 1 for the x squared. You can rewrite this as x plus 1, x minus 1, over x minus 1. If how I did that confuses you, make sure you ask questions, and a little bit later in the lesson we have some practice problems. Make sure you ask questions about it. But once you have this, you can cancel out these. You have x plus 1, and with x plus 1, you guys can clearly see that 1 plus 1 will give you 2. So that's how you get that the limit is equal to 2. I need to actually rewrite this a bit because I forgot something. So if I want to factor, I still have to have the limit operator. It's a very important part. The limit operator has to stay there until we are done evaluating the limit. So I have to keep that for the whole process until we actually plugged in 1 and figure out what that is. So then I cross this out. Limit x approaches 1, x plus 1. to note, I still have the limit operator. This is finally where I get rid of it. That's when I plug in the 1. Whenever you plug in the number, that's when you get rid of the operator. But until you plug in that number, you have to keep the operator. We can do a very similar process for this one. I'm not going to talk about it as much because it's basically just the same steps. 4 is the same as 2 squared, or 2 times 2. So what we're going to do is do this exact same thing. X plus 2. And if you notice, once again, we have something that cancels. You have the same on top and the bottom of the fraction, which means we have limit as x approaches 2, x plus 2. Once again, we keep the limit operator until we have completely simplified it and plugged in the number, and that will give us 4. So I saw lots of people had that answer already. If any part of this is confusing, I would encourage you to write it down somewhere you can, or take a picture, and then make sure to either ask about it or look at some other examples and figure it out. I want you guys to be successful in this one.
Wait, Mr. Lin, would either or method work?
Yes, both methods work.
Okay. And it's always like all the time that they'll work, or would it be like some you had to use one method and some you had to use the other?
I would say some you have to use either. So, the table method will work for every single problem.
Okay,
Every single problem. It'll either give you an answer or it'll tell you that you can't have an answer because it bounces between positive and negative. Okay?
Okay.
That's a good question. This method only works when you have a quotient and a factorable polynomial.
Okay.
There are some polynomials that this won't work with because they don't factor.
Yeah.
So that's an excellent, good point. All right, we'll leave this up here because the next thing we're going to talk about is the exam. So a lot of you had some where you got the right answer but didn't put the right notation. So if that is the case, I would pick off 2 points. So if you just, for example, so I'm going to leave this on here, move it up a bit. If you were asked to evaluate a limit, and all you did is do the table and then finish the table and write your answer and circle it, but didn't include the limit as whatever that is approaches. The reason I counted that one wrong is because I want you guys to remember to actually put it there. Because if you go to an AP test, they're going to be expecting you to have that limit operator there when you write your equal sign. If you just put 2 and circle it, then they're gonna be like, 2? What does this apply to? Is it just, it's just a random number. So you have to state that the limit as x approaches 2 is equal to 4 or something like that. Okay? So if you lost some points, if you see a -2, it's because you had the right answer, but you were missing some of the pieces that you needed to have an AP answer. The continuity at point problems, if you did not show the different suppositions, if you just said it was continuous and didn't show that 1, the function values exists, or basically just plugging in the number, you didn't show that the function value of, let's just do an example. Let's just do that problem. I'm gonna take that one. Alright, so our equation was x squared. You can all take equation for me.
X squared plus x minus 6 over x squared minus 4.
Alright. And ask for continuity at the point 3, right? The key factors to get the question 100% right, where you need to show that the function value at 3 of this equation equals something. It has to equal something. So that would be directly plugging it in. then you have to show the limit as x approaches 3 of this over x squared minus 4 is equal to something. If you guys remember, we had suppositions that we had to do, supposition 1, supposition 2. And the third one was that these two should be equal to each other. So that was, if you wanted to get full points for those type of problems, that's what I was looking for, is if you had, like, this is true, because they're the same, we can say it's continuous. Okay? The continuity at interval is suffice to show if it was not continuous. That one, most people, I think most people have that one, or at least did well enough on that one. The last problem I want to talk about is the in-behavior problems. So a lot of them I asked for, what was the in-behavior of this function? What would it look like? There ways you can justify your answer are by looking at a graph and like drawing the graph out and saying, well, as it goes out this way, it's approaching a single number. The other way you can justify it is if you use, and this is the more proper way, the limit as x approaches infinity for, we'll just use the same one. So if you remember to do that, you could have put in like different big numbers. So like you could have plugged in 100, 1000, everything like that. Done it that way, done our table, and then you would have found out this is actually approaching 1. So I don't know what the values are, but you could have used like you could have set it up like that to figure out that problem. Okay? Does anyone have a question on a specific exam question? So if you look through it, were there anything that you guys got wrong, that you had a specific, that you would like me to look at, actually work through the problem? Now we're all happy with like Ray's understand them, know what to do differently?
The bonus question.
The bonus question, okay. That was the piecewise one, right?
Yes.
Alright, I don't have all the questions memorized by heart. I know it goes something like f of x is equal to, and then it has
Sine
sine
of
x,
x squared
x squared,
and x minus 3.
x minus 3, okay. And what were the limitations for each one?
X lesser than 0.
Less than or equal to?
Yeah.
Okay.
Just less than.
Just less than? Okay. And then,
0 less than x, which is also less than 1.
and then this one would be x greater than or equal to 1. Alright. So this is our problem, right? What was it asking us for again?
All values of x is f not continuous.
Alright. So the first thing we need to note is, what is the domain of each of the functions? And we can use our chart that we have, right?
Yeah.
So if we use our chart, we would get our domain for this function is negative infinity to positive infinity. So we know that one's going to be continuous for every x value that it has. The same for this one, and the third one. So all three of them have infinite domains. Does that mean it's continuous everywhere?
Yeah.
Not necessarily. Because remember how we looked at some of the graphs of piecewise functions, and they sometimes have that jump where they have a value, but it jumps from here to here. If it has that jump, it's not continuous. So that's what we need to look for. So if we're looking at this problem, what values do you think the important values would be to look at?
Like.
When does it switch equations?
The ones in the middle.
So 0 and 1. All right.
Like the greater than equal to.
Okay, yeah. So the x values that are most interesting, or the ones that are going to determine if it's continuous or not, are in fact, yes, the 0 and the 1, or the ones where it has to be less than or equal to. But then we need to figure out how exactly do we evaluate that. So in order to evaluate the bonus question, you would have had to do limit as x approaches, we'll use 0, because it's the 1. And you'll have to evaluate from the left. Okay? So we're evaluating it from the left side first. In order to evaluate it from the left, you have to look at which of our inequalities accounts for values left of 0 on a number line. Our first one, our second one, or our third one?
-2.
What?
-2.
Minus 30. So this incorporates values to the left of x? Was that left of 0?
Oh wait, no, the top one.
Yeah, that one says left of 0, right?
Yeah.
So then that means we're going to use, for the one to the left, you have to use the one where it's to the left. So you have to use the inequality where it says to the left. Now, this is probably where a lot of people would get stuck. This is the hardest part to grasp, so I'm going to talk through it for this first one, and we'll do it together in the second one. So, as you're approaching it from the right, we have two things that are to the right of 0. We have two inequalities that say that to the right of 0. Because if it's in between 0 and 1, it's to the right of 0. And if it's bigger than 1, it's to the right of 0. So how do we know which one to use is by which gets closer to 0. Is 1 closer to 0, or is 0 closer to 0? 0 is closer to 0. So then you're looking for which one gets closer. So this one, middle one, gets closer to 0 than this one, right?
Mm.
So then we're going to use this. So that's how you would go about choosing which ones to use for that particular point. Okay? You would first look at, which ones are to the left of 0? Well, that equation is what we use. Which one's to the right of 0? Well, there's 2, so which one's closer to the right? And then you use the closer one, which would be x squared. Typically, you also go down in order. So like, typically they're written in the order that you use them. So even if you forget, if you just follow the order, you'll typically be fine. Alright? You can still use direct substitution to evaluate these two limits. So what is the sign of 0? Put it in our calculator and using the trig function. Zero. Alright? And then we all know if you have 0 and you multiply by 0, you still have 0, correct?
Yeah.
So that means this is still 0. What do you notice about the two values?
They're the same.
They're the same. Which what that means is because these are the same, at 0, this function is actually still continuous. Because they overlap. They combine at that point. There's no jump. Alright? So if you get the same value, it's continuous. Now let's look at the counter argument. Because this is where the hard part was. So as you approach 1 from the left, so you have to, and as you approach 1 from the right. Alright. So we have 2 that approach 1 from the left, right? Which one gets closer to 1 on the left? The top or the middle?
Top.
That gets closer to 1? Or does that stop before? Which one gets closer? Middle. Yeah. So you're gonna end up using the, typically in piecewise functions, you'll end up using the middle ones more than once for this type of problem. So if you'll note, we end up using x squared twice because it's in between two numbers that it's looking at. So it's really close to those two numbers, but it's in between them. And then there's only one that's to the right of 1, correct? So then you use x minus 3 here. And then you still just plug in 1, so 1 squared is 1. And 1 minus 3 gives you -2. Are those the same?
No.
No,
So what does that tell us?
that's
not
where they're
continuous.
confused.
That's what they are not. If they're continuous when they are the same, it is not continuous when they are not. So that's where the jump is. Alright, that was a good question. That was probably the hardest question on that's why I made it the bonus question. Alright,
I kinda got it the easiest stuff, like after this.
yeah, that's good. So, are there any other questions you guys would like me to work through and talk about from the exam? Before we move on?
How about whenever it asks me to determine if a function is continuous over the interval and it gives you 2 points, I didn't know how to go about that.
Alright. So, that's a good one. Do you have a specific function that you were looking at for that one?
Just in general, how to set it up.
How to set it up? Alright. So, I'm going to use our Bellringer one, just for an example. So let's just say we have our function is, not 4, I'm going to 2 that. It's 2 minus 4, that's a good question as well. So say this is our function. And say our interval that we wanted to check was from 2 to 7. Alright? The first thing we need to do is we need to check out what is the domain for our function. So if we were to look at this, what values, we need to figure out what values aren't. So do you remember our domain chart?
This is the one where we have like all the functions.
Yep. So I would we're gonna reference that. So I'm looking for the one that has the division. We had a very special rule for that in our chart. You're gonna need your notebooks out anyway, so if you don't have them out, I would recommend getting them out. The next thing we're gonna do is do more notes. We're gonna talk about derivatives. So if we're looking at our chart, our very fancy, like our nice function chart, we have one that has the division part. Fx over g of x. And what was our condition for that one?
All real numbers except for when g of x equals 0.
So all real numbers except for g of x equals 0. So this is our, at the top is our f of x, right? And the bottom is our g of x. We know that the only number we're not allowed to have is the one that makes g of x equal to 0, correct? So then we just solve 0 equals x minus 2. And we solve that, we know what numbers are not in the domain. To solve this, it's 2. But you just add 2. You're solving it mathematically. So you have 2 is equal to x. So, that's the only number where that function is not continuous. Is that number in the interval?
Yeah.
So is it continuous over the interval? There you go.
Okay. But
If, say for the example, the interval was 3. We know that's continuous over that interval because the only point it's not is 2, right? So typically, the way you check for continuity of an interval is you look for if it's where the points are that it's not continuous. So like if you got a piecewise function that was asking you that same question, like over the interval is it continuous, you would look at all the points that we did in the last problem, the bonus problem, and you say, okay, are there any points that it's not continuous? And that's what you look for.
so what would you do with the 7? It's like 3 and then the next number 7. I don't know. We're looking for which one is like if the domain right now.
Yes.
This is 3. So what would we do with the 7?
So all you'd have to show if I ask you about this interval is like this work right here. Because once you have this, you can say this function is continuous for all numbers except 2. Except x equals 2, to be precise. So, if you say this, that covers for this. It covers for the 3 and the 7.
And is the 3 and 7 like a point, like x, y? Is it
No, it's just 2 x values.
Okay.
So it's saying, this is saying any x, it wants to look at the interval x values from every number from 3
Oh,
to
two,
3, 3.1, 3.2,
Mhm.
all the way up to 7. So it's all the numbers of x from 3 to 7.
I thought it was like asking, like if there was a point on that like x, y, that's what.
Yeah, gotcha. That's a good clarification, yes. So yeah, intervals, when it comes to, limits and derivatives typically, are going to be saying x values from, 3 to 7. That's a good clarification, so I'll say. Alright. Good question so far. I'm gonna call that for our exam relook over because we need to keep moving. Let's give it about 30 minutes for our review. If you have more questions or are not happy with your grade, you're welcome to come to one of my times I had for tutoring, either during lunch or after school, and then work on how to get the grade up from there. So anyone who is not happy with it can do that. Let's see. I don't think I need to make any other things for that. But you can get out your notebooks, please, and we're going to start talking about derivatives. We're first going to do some definitions. In order to talk about derivatives, we need to have some definitions down so we can reference them and you guys know what I'm talking about, right?
It's a big one.
I would start a new page if you haven't already done so. And we're going to title this page Derivatives. And if you want, you can put a subtitle of definitions. And one of the things I'm going to work on for this unit is I'm going to be referencing our definition page a lot more. I'm saying, okay, here's our definition. Here's this word. What was our definition for it? Things like that. Okay? The only things we're really going to have for definitions for this unit that we don't already have is going to be the definition for a derivative. So a derivative is the instantaneous rate of change. What does instantaneous mean?
Quickly.
Very fast. In fact, so fast you can't even tell that any time has happened. So, instantaneous rate of change. That's the simple definition for it. We'll add a bit more to this as we go, but that's basically all you need. Now, rate of change. Does anyone remember the definition for slope?
I know it's right so we run, but.
Let's add slope here. Slope, it is rise over run, like you said. It's also rate of change. I left a space in between on purpose. I recommend leaving a space in between. So, anything you notice from the two definitions? both using rate of change. If I want to be precise and like calculus precise, slope is the average rate of change, and derivatives are the instantaneous rate of change. So you could call the derivative a slope calculator. You could call it that. You wouldn't be wrong. Let's see, other definitions. We already defined continuous. We already defined, did we do a difference quotient yet? Yeah. This is gonna be important, and we're gonna talk about, this is actually what we're gonna be talking about a lot today, is the difference quotient. Because in order to start talking about derivatives, you need to first do the difference quotient. The difference quotient is, it's gonna just be an equate, like a formula like thing. So it's, we'll define this more in detail as we go through it, okay? This is just the overview. Hold on, it might be multiplying. It's been, I just looked at it earlier, but. One moment, please. Okay. I was more or less right. So it's just, it's, the triangle is called delta. So let's label this. This is delta. It's a Greek letter. And that just means change. Yes. So
Mr. Mayor, can I look at this one?
yes. Oh wait. I'm not allowed to do passes during lunch. Sorry. Alright. That's all the definitions we have currently. But leave some space on the page because we're gonna add more definitions to this page later, okay? So I recommend going to the next page, or at least start going halfway down before you write any more. We're gonna add more definitions later because there's a lot about derivatives. We're gonna be talking about derivatives probably until like late February, because there are so many different things that you can do with derivatives. Derivatives are the most applicable part of calculus. There's so many different types and so many different things you can do with them. But we're introducing them here. We're working with them a lot. Notes on the definitions? Anything? Any other notes? Any other interesting facts? Alright, here's what we're gonna do. I want you guys, we're gonna use the whiteboards for this one, to talk to someone at your table, and I want you to note what's the difference between average rate of change and instantaneous rate of change. That's the question.